Hello guys, in this video we will be using the Monte Carlo simulation to perhaps generate pi. So throughout the video I will be giving visual representations and also short one-line code examples. So first what we will do is we will create sets of x and y coordinates, which will give us so basically we'll create a graph from -1 to 1, x and y, and we will plot some random points onto that graph. Right. So yeah, so we'll use the uniform function of the random module in Python to do this. So yeah, we have a graph -1 to 1, both x and y, and it has 100 random points. Now what we do, we have to create a kind of a virtual circle. This step is not necessary because it will be this virtual circle will be created there anyways. This is just for visualizing. So yeah, we create a virtual circle, and we have to get the number of points that are inside the circle and the number of points that are outside the circle. Right. So yeah, the radius here, the reason I'm using 1 is because the radius is half of the diameter, and the diameter we use here is the length of our graph, which the length would be 2, because -1 to 1, the length would be 2 for that. And yeah, so, and of course 2 divided by 2 is 1. So yeah, position 0, 0, which is the middle, which is yeah, like this. And now and again, this step is not necessary because when we get so we will see next here. So now we have to determine, for every point we have to determine if it is inside or outside the circle. We will do this by getting the difference between that point and the origin of the graph. So yeah, and this will kind of create a circle for us, because yeah, this will create a circle for us. So we did not really need the previous step. That was just for visualization. So yeah, the distance we have to square. Yeah, this is just a simple formula for getting the distance. I'm sorry, I said difference here, but it's the distance between that point and the origin. So, and if the distance is smaller or equals to 1, then that point is inside the circle. Yeah, right here. Now we must calculate pi. So what is pi? Pi is the circumference divided by the diameter. And so yeah, but here we have a square, which kind of makes it a little bit simpler for us. Now we can do the area of the circle divided by the area of the square. But they also must be same units. So we cannot really do we cannot do the size, which is, we'll see. So what we can do is we can just, so we divide the area of the circle, which is pi r squared, by the area of the graph. Yeah, so let's do that right now. Yeah, it would be this. Now, yeah, so we multiplied by 4 because that's kind of like a margin for us. So yeah, this should give us pi. But this would not be super accurate, because of course for it to be 100% accurate, it would have to take a super long time, because what Monte Carlo essentially is it's just kind of like a brute force. You use random samples to get a result. And yeah, this is essentially a brute force. So yeah, the accuracy would depend on the size of the loop, and the bigger the size of the loop, the more the more computing power it needs. So although I am doing it in Python, but the only reason I am doing it in Python is just to make it easier to read. I have tried doing this in Node.js, and it worked much faster than Python. Of course, if you do it in C++, it will work much faster. But unfortunately, I do not know enough C++ to do so. But yeah, here's a simple graph that demonstrates the accuracy of the Monte Carlo simulation with the size of the loop. Essentially, what the size of the loop is, it's the total amount of points. It's the total amount of points that are on the graph. So yeah, you can check the full code for this on my GitHub, which is in the description.